I was out sick on Friday, so I got homework Wednesday. Yo, Vision, what did you get? No, what do you get? Like,
We're going to start our quiz review today. Quiz will be on Friday. So it'll cover solving differential equations, slope fields, verifying differential equations. Okay. This will probably take us 2 days to get through. So we'll work on it today, work on it Wednesday, and then Thursday I'll try to put together another worksheet for you, and then Friday quiz. Okay, so there's a little bit of related rates here to begin the problem, but it's not much, just to get the derivative equation going. Okay, so Mr. Bean's favorite drink is put into a cylindrical container with a radius of 3 inches. Let h be the depth of the soda in the container, where h is a function of time measured in minutes. The volume is changing at a rate of -π/2 root h inches per minute throughout the morning, given that h equals 9 at the start of the first period. Solve the differential equation for h as the function. Okay, so it says the volume is changing at a rate. What does that mean here? Yeah, so dv over dt, right? So we know dv dt over here. We can also create a dv dt from this side of things, right? Because we know that, well, the nice thing about a cylinder is that we don't have to go through similar triangles. It's not as messy as cones, right? And also, what do you know about the radius for cylinder here? Radius is, does it change? Doesn't change, right? So we can start off our guys. We can start off our derivative process. Just jumping to power rule here. We can find dv dt, right? 9πh becomes related rates. 9πh becomes 9πh becomes dh dt. Okay, so we can set our equations equal to each other here, because now I have everything in terms of h and t, and then we can begin solving the differential equation in terms of h, right? So this is how we get to that, get to our differential equation. Okay, so I can say that 9π dh over dt is equal to cross multiply here. I'm just trying to separate the variables, right? I want to eventually solve for h. I need full separation of variables, so I know we're probably used to having x and y in our equation here, but if you have equations, if you have variables other than x and y, it'll always be time t and another variable. Okay, so t is always your x, and then whatever the other variable is, that's your y. Okay, so here we want h's on the left, t's on the right. So we have at least our initial lined up, but what is still out of place?
The h on the right.
The h, yeah. And how can we move that h?
Divide
it, yeah. And then the 18 pi, it's not wrong to have 18 pi on the left side, but we talked about how our left side, we just want to have as minimal as possible, right? Keep it to be as minimal as possible, because eventually all you want is you want to solve for h, and if you put things on the left, one way or another, it has to come to the right towards the end. So I'm just going to move things as I can. So the root h, I'll divide, and I'll divide the 18 pi over to the right side. So I'm doing a double division here. I'm moving the pieces, dividing the appropriate pieces to the left and to the right. Okay, so left side, I can get this ready for power rule, right? I don't want to leave this in denominator. This is not a natural log rule here, because it's just root h. If it was just h, the first power in the denominator, then we do natural log, right? But any other power, we got to bring it up and do power rule. The left side, the right side cleans up to be just what?
Negative.
Mm-hmm. Okay, power rule. H to the negative 1/2 becomes,
H to the 1.
yeah. Power rule on the right side as well. So there's two things that's left that we needed to do. We have to solve for C, and we have to solve for H. Okay, the order doesn't matter. Okay, if you want to solve for H first, then solve for C, or we can solve for C first, then solve for H. I don't really have a rhyme or reason. I kind of, if I feel like an equation is simple enough to solve for H, then solve for C, then I typically solve for C. But sometimes I wait till the end because I feel like that's an easier equation. So you guys can do, you know, even if our C values don't match, at the end, our equations should be the same. Okay. So in this case, I'm going to just solve for my order pair first, my C first. So I have, I know that at t equals 0, h is 9. So at t equals 0, h is 9. So I can replace h with 9, 0 in for t, solve for C. And once I solve for C, I can then work on try to get that h by itself. Square root of 9 is 3. 3 times 2 is 6. C is equal to 6. Okay, so now to solve for h, I'm going to divide by 2 and then square both sides. Or multiply by 1/2 and square both sides. Okay, any questions? Sometimes I just wanted to make sure that when we solve different equations, some of my students would feel a little they would feel like the problem feels a lot different if it's not X and Y. So just keep in mind that if you see other strange variables in your differential equation, that strange variable is always paired with T, right? And so T is your anchor, right? T is your X, and whatever variable we don't recognize, whether it's Z or B or H, that's your quote unquote Y. Okay, so any questions here with one? So number two, we're also going to see that combination of different variables that we are typically not used to working with. But here, this is rate at which baby koala bear gains weight is proportional to the difference between its adult weight and its current weight at time t equals 0. When the bear's first weight, its weight is 2 pounds. If b of t is the weight of the bear in pounds, then dB over dt is 1/4 times 20 minus b. Find y equals b of t, the particular solution to the differential equation. So we're going to separate the variables just like before. In this case, instead of h, it's b, and then time is still our independent variable, right? So we'll just spend the time to separate our variables. I like to cross multiply to get my dB and dt in their right places. And I like to do this cross multiplying just so that I have my dB and dt locked in. I know those are my anchors. Now I can worry about separating variables, right? I want my independent on the right. I want my dependent on the left. So what can we move? B. Right? How would you move it? Divide by 20. Good. So this parentheses helps remind us that we don't move just this b alone. The 20 is attached to it. So if I want to move the b, I got to move that 20 minus b along with it. Okay, so it's going to end up dividing to the left side, which is fine, right? If it ends up in the denominator, we still have a rule for it. What else could we move? This one is not as important, but I like to move it if we can. The 4, right? The 4 doesn't have to be on the left side. Let's just go ahead and move to the right. Okay. So both the 4 and the 20 minus b will end up in the denominators on the opposite side. Right, full separation, right? B's on the left, everything else on the right. Okay, everybody okay with dividing over and getting those lined up? Okay, right side is easy. Right side is power rule. Left side, we got to go through a little bit of what? U substitution. And when we go through U substitution, eventually we're gonna what rule are we looking to use here? Natural log, right? 1 over u du. We do have to go through U substitution because this 20 minus b will produce a -1, which will come into play with our derivative. Okay.
Variable problem.
I'm sorry?
This is the change of variable.
No.
Okay.
This one is just when you go through your substitution, there's going to be a -1 left over. That's all. That's all that's going to come from out of this. I think what's the derivative of 20 minus b? Just -1, right? So just like keep track of that -1. That's all. Okay, so 1 over u du is just natural log of u. I'll replace the u back in terms of b, but I gotta make sure I carry that -1 through. Power rule on the right side. So in this case, I'm going to solve for B first. I just feel like solving for C is a little messy at this stage, but sometimes I don't have a rhyme or reason for when I would solve for C. I just look at a problem and it, sometimes I prefer to solve it earlier if it looks easy. Sometimes I prefer to solve it later if I feel like I can get this equation cleaned up. So I do want to, I'm going to solve for B first, but to solve for B, I want to involve E in natural log, but this negative is kind of standing in the way. I'm going to just make it distribute to the right side here so I can get that left side a little bit cleaned up. Raise both sides with E as the base. This is E to the negative 1/4 times E to the C. I can turn that E to the C to just one big constant. I can also drop the absolute value, and let the C absorb that plus or minus. Okay, let me solve for B here. Okay, so there's my general equation. I have an order pair that I can use to help me solve for C. My order pair is 0, 2, right? At time t equals 0, the bear is 2 pounds. This will help us solve for B. Okay, any questions so far? All right, number 3, consider a differential equation. Let y equals f of x be the particular solution that passes through 2, 0. Write equation for the tangent line, then use tangent line to approximate f of 2.2. So this is just linear approximation, right? You get the order pair, you get the slope, point slope form, and then you just plug in the decimal value. So dy dx, I know this looks a little bit different than other derivatives, but it's still a derivative. You give it enough information, in return, it'll give you a slope value, right? So we have our point. Let's work on finding our slope. Replace e with 0 and x with 2. Anything to the 0 power is 1. 8 minus 1 is 7. So my slope is 7. I have my order pair. I have my slope. Point slope form. And then we'll just plug that decimal in to do linear approximation. Okay, part B, we're asked to find a particular solution. So we're going to solve the differential equation. So we separate the variables, solve for C, and then solve for Y. a little bit of U substitution, but all the U substitution is going to do is to make sure that we keep track of a -1. That's going to be part of our e to the U rule. So the rule for e to the U is just e to the U, but that -y, which is to make sure that when we take the antiderivative, that we keep track of the fact that there's a coefficient of -1 that's going to be left over. Wait, my bad. Okay, so I solved for C first. Now I'm just trying to figure out how can I get Y by itself. Let me multiply everything through by -1. Then I can involve natural log on both sides. Okay, number 4, more of the same. Go ahead and try those A, B, and C. Change that equation. Then part B, a little bit of implicit, but I can walk through part B if you're stuck there. And then part C is, at the end, solving differential equation. Y is on the left, X is on the right. A little bit of U substitution that's involved there as well. Okay, so number four, part A, pretty straightforward, right? We can just take our order pair, put into our derivative to get our slope. Once we get our slope, point slope form. Linear approximation here, plugging 0.6. And whatever decimal we get, that's our answer. Part B says find the second derivative. So we have d by dx. So if I want to find the second derivative, I get d2y to dx2. I have to go through a power rule on the right side here. 6 becomes 0, negative 2y becomes negative 2 d by dx. D by dx is the original equation. So if I replace d by dx with the original equation, there's my second derivative in terms of y. I can use that to plug in my order pair and getting a second derivative value of 4. That's a positive number. So if it's positive, I know that my graph must be concave up at that point, since second derivative is telling us about the cavity. This problem didn't ask for it, but if it's asking whether this tangent line is under or over approximation, you know that the graph that is concave up, your tangent line is always sitting below the curve, so under approximation. I know it didn't ask for it, but I just want to just make that connection with something that we've seen in the past. Part C, we're just separating our variables and going through our process like number 3. Okay, so let's try that. Okay, word problems involving y equals CE to the KT. Number 5. During a certain epidemic, number of people that are infected at any time increases at a rate proportional to the number of people that are infected at that time. So P prime equals KP, which we know that will just turn into P is equal to CE to the KT. So gathering a bunch of information here. Usually the process is solving for C, then solve for K, and then using that to find the number of people. So time, population. So when the epidemic is first discovered, we'll let that be T equals 0. $800 people, 505 days later. How many after 10 days? So the 0, 500 can solve for C, and then we can use the second order pair to solve for K.
We can calculate for this.
Yeah, you do. Okay, I want to see you holding on to your K value and not using decimal approximation till the very end. So now we can plug in 10 in for T, and then we can use our calculator to find the approximated population. Okay, take a look at number 6. It's a little bit different than what we've seen, but we can still solve it. Everybody okay with 5? So number 6 here, it says population of fruit flies increasing at an exponential rate. So we know it's going to be P equals C to the KT. On the 3rd day, there were 400 flies. 7th day, there were 600 fruit flies. How many were in the original population at day 0? So this one, what we can do is we can plug both of them into our original equation. And if we can solve for C with both of the equations, then we can set these equal to each other, right? And our goal is, okay, if we can use this to help us solve for K, then we can go back to the original equation and then use any of the ordered pairs to solve for C. Right, so this is our initial setup. Okay, we're gonna have to use our 2 ordered pairs to solve for K. So So if I rearrange the equation, C is equal to 400 over e to the 3k, C is equal to 600 over e to the 3k, e to the 7k. Set those equal, and then we can work towards solving for k. All right, so if I cross multiply, I get 400 e to the 7k equals 600 e to the 3k. Let me put the e's together, put the constants together. Remember, if I'm dividing bases, I can subtract exponents, right? E to the a minus e to the b equals e to the a minus b. So that gives me e to the 4k equals 1.5. So now this feels easier to work with, right? Take the math on both sides, solve for k. Once you solve for k, then update our equation. And now we can use either equation to solve for c. Now that we have k, we can insert k into either one of these. I chose the 600 one, but the rest just go into calculator here, 295 plus. Another exponential equation for number 7. So let's see if we can get through 7 and a little bit of 8. Okay. Any questions with 7? Okay, so we'll stop there. We will pick up on Wednesday. I didn't get a chance to check homework for 7.3, so I'm gonna check 7.3 homework and the cumulative the last two pages from your packet. I'll check that on Wednesday. We'll do the quiz review Wednesday. I think Thursday we'll spend another day reviewing. I'm going to push chapter 8 to begin next week. Okay. All right, because
Second derivative, right?
Yeah.
I like that's the derivative.
that's it.
So wouldn't that be negative?
You might get 10.
So the second derivative is negative.
In relation to x, so a little differential. There's a little implicit. It's 2y becomes 2 dy.
Yeah. Also, we got two. I don't know. I mean, it's such a nice reading writing. I got it. What you guys report?
You should do what problems to catch. No, those.
I got the more.
I made stuff.
Probably got like a no. I think like 2.95. Robert.
I know.
I got like not high, but I'll have like a worse.
What's broken what?
They got two.
What do you mean worse than the SAT?
Like, if you guys, they both got 13 days. That's where they got all the.
Really?
I think reading it.
Yeah, this is really, why is it? Five. Negative 3.
Exactly. Oh, dude, yeah.
Oh, yeah, 46. Maybe you get some fun and talk.
That's gonna be really fun.
You're gonna get that like for 3 years.
Just.
Yeah.
Are you going to get it? That's a really.
Oh, I am so good at.
But about that.
You got 15
Good.
The max.